In lesson 2.5, we're going to look at percent problems, and we're going to look at some pretty basic problems, and then we're going to look at a couple word problems. But a few of the key terms and things you need to keep in mind when you're working with percent are key words. And the first one, of, translates to multiplication, is translates to equals, what number translates to any letter variable, and percent translates into times 1 over 100 or times 100th or 0.01. One thing that I want to add to this is there's two different ways to solve percent problems. You can translate using the key terms, or you can use a percent proportion, and a proportion is just two equal fractions. And the way I remember that is a percent is always out of 100, and the other fraction is the is over the of. And so this is one way to solve percent problems, and then translating into an equation is another way, and I'll demonstrate both of those methods in the next few problems. So if we look at number 5, two different ways to set this problem up. If you're going to do what percent of 240 is 156, since we're looking for the percent, what we can do is translate into an equation, or we can use the percent proportion. So if we translate this, what percent, as we said earlier, translates into, and I'm going to use the decimal equivalent, 0.01 of some number. So we'll just say, what variable do you want to use? We'll say p. So times p. And then we have the of 240. So now we have to times by 240. And then we have our is, which means equals 156. So on the left side, I could actually do some simplification here. 0.01 times 240, because everything's being multiplied together. So I could actually multiply the new two number pieces together. And 0.01 times 240 is 2.4. So I really have 2.4p equals 156. Now I can start solving. Divide both sides by 2.4. And I'm going to get x equals 65. And since this is a percent, it's 65%. The other way that you can set this problem up is to use the percent proportion. So that's the is over of equals percent over 100. So the way I would set that up, I know I'm looking for the percent. The is 156. The of is 240. When I solve a percent proportion, or any proportion, we find what we call the cross products and set them equal to one another. So I would have 240p is one cross product. The other cross product is 15600, or 15,600. Now I would divide both sides by 240. And I get 65%. So both methods work, whether you translate into an equation and solve, or you use the percent proportion. My preference is to use the percent proportion because it works on any percent problem, whether you're finding the percent or the is or the of. Translating, you would get 3 different types of equations, but it's still doable. I kind of bounce back and forth, but I tend to navigate more towards the percent proportion. So let's look at another one. How about, we've already found one that uses the percent, so I don't want to do another one of those. Let's do, we'll do number 9. What number is 55% of 280? Now, this type of problem, I would actually translate this because it's going to translate very nicely. So what number, so I could just say x is 55%, so 0.55 of 280, so times 280. So the equation is already laid out very nicely. Of course, I could do percent proportion as well, but it's going to be a little bit more work. So 0.55 or 55 hundredths times 280 ends up being 154. And so that would be my final answer for number 9. Again, you could use percent proportion. If we were doing the percent proportion, I would have, go ahead and get my fraction bars, put in my 100. My 55 would go in the percent. The is, I don't know, and of would be 280. So that's what my proportion would look like. And I would have a little bit more work involved once I do cross products, but in the end I would still get x equals 154. Okay, so now let's jump down and we'll do number 13. Oops. 7 is 2% of what number? So if we were to translate this, it would be 7 is equals 2%, so 0.02 of what number? So we could just say times x. So that's how it would translate. If I were to do the percent proportion, I have 2%, so the percent always goes over the 100. 7 is, so I have my 7, and I'm looking for my of. So that's what the proportion would look like. Either way, you're going to arrive at the same answer. If we do the translation, then I would have to divide both sides by 0.02. And 7 divided by 0.02 is 350. So x equals 350. If I'm using the percent proportion, then I would do cross products, so I would get 2x equals 7 times 100, 700, and I would divide both sides by 2, which also gets me 350. So again, you can solve it whichever method you prefer, whether it's the translating or the percent proportion. Now on a couple of these word problems, I'm just going to set them up. I'm not necessarily going to solve them because the key to solving word problems is the translating. Once you translate into either a proportion or an equation, then it's just doing the computation in the problem or the equation solving process. So I'll set up a couple of these, but I'm not going to work them all out. So let's first look at 18. If we were going to set that one up, and I like to use the percent proportion on these. So in 2006, David Ortiz had 160 hits. His batting average was 0.287 or 28.7%. So there's my percent. And make sure, because it's always the percent over 100, that you use the percent format. Don't use the decimal format. That is, of the total number of at-bats, 28.7% were hits. How many at-bats did he have? So the only other number we have to work with is the 160, and those were hits. So you have to decide, is that your is or is that your of? Well, if you logically go through the problem, your 160 hits is going to be a smaller number than the total at-bats, because at-bats is going to include if he walked, if he struck out, all of those scenarios, or got thrown out. So 160 is going to be the smaller of the two numbers. If you look at the fraction that we already have, the smaller number is on top. And that's why I like to use the percent proportion on these. It kind of helps me logically set it up correctly. So my 160 is going to be at my hits, and my at-bats is going to be the of. And so my smaller number is in the numerator or the top number in both fractions. So that's just kind of a reminder that I do have it set up correctly, or if I'm wondering, do I put the 160 in the numerator or the denominator, this helps me make that decision. And then I could go through and do my cross products from there. And if you go ahead and solve this one out, the answer ends up being approximately 557 at-bats. And again, you would just do cross products to find that out. You could also use a percent proportion for number 19. Chad left a $6 tip for a meal that cost $30. What percent of the cost of the meal was the tip? So the way we would set that one up would be, I don't know the percent, so I'll just put that above my 100. A $6 tip for a meal that costs $60. So you have to decide which is your is and which is your of. Well, you know that the tip is going to be smaller than the cost of the meal, just like the percent is going to be smaller than 100. So your smaller number will go on top and your larger number on the bottom. That's not always the case. It depends on what your information you're given. So then when I go through and solve this one, again, I would do cross products, and I would get, my percent ends up being, I believe, 20%. And then for the total cost for the second part of this problem, you would just take, the total cost would be the cost of the meal plus the tip. So that's really just 36, or I'm sorry, 30 plus 6, which is 36. So there's your two answers to the problem. There's your total cost, and there's your percentage. The last type of problem we're going to look at is what we call a percent of change, and in this particular problem we're looking at a percent of increase. It doesn't matter if it's a percent of increase or decrease, you still solve the problem the same way. So when you're working with what we call percent of change, the way you set up the problem is still very similar. I like to use a percent proportion. So fraction, and actually fraction equals a fraction, and we still have percent over 100. And the way our first fraction is going to set up is the amount of change. So the amount of change. So how much something changes over the original amount. And again, this will work for whether it's increase or decrease. So for this particular problem, we don't have a percent, because that's what we're being asked to find. The amount of change, so there was an increase of from 467,000, I'll go ahead and just highlight that, to 488,000. So how much of a change is that? Well, we actually have to do some subtraction. So 488, I'm just going to come over here off to the side, minus 467, and since these are both thousands, it looks like we have a change of 11,000. So I have 11,000 is my amount of change over my original amount, which is 467,000. So when I go to do my percent proportion, I've got it filled in. Now I do cross products. So I'm going to have 467,000 times my unknown is going to equal 11,000 times 100. So 1,100,000. And now I would divide both sides by 467,000. and do one last division. I just realized I had an error in my computation. It should have been not 11,000, it should have been 21,000. So that's going to affect my computation. So it's really 2,100,000 divided by 467, or 467,000. So when I do that final division, I get my percent is approximately, because I do have to round, looks like 4.5%, and that's my final answer. And that is a percent of increase.